All right, so this next section is going to be on arithmetic sequences. And an arithmetic sequence is one in which the value of each successive term is found through adding the same value, called the common difference, and the common difference will be denoted as a D, and to the previous term throughout the sequence. And the explicit equation for finding the value of any term in the sequence is going to be a sub n equals a sub 1 plus n minus 1 times d, which is your common difference. All right, so let's think about this equation for just a minute here. Let's suppose that we have the sequence of numbers 2, 5, 8, 11, 14, and 17. Now we're starting with the value of 2, and to that 2 we are adding a number consistently throughout the sequence, and that number is 3. And so for the first term, or for the second term rather, we added 3 one time. For the third term, we added 3 two times. For the fourth term, we added 3 three times. And for the fifth term, we added 3 4 times. All right, so if we compare things a little bit here, to get this 5, we added 3 to the first term, so we added 3 to that 2, and we added it just one time to get this. To get the third term, we added 3 two times. Now, look at this number compared to this number throughout this process. This number is always one less than the term number that we are looking for. And so what we did is we were taking how many times we were adding the 3 and multiplying it by that 3, which was our difference. Well, that number here is always one less than this one. That's where this formula comes from. Whatever term it is that we are looking for, this number is always going to be one less than that. So you'd have 5 times 3 or 20 times 3. So for example, if I want to know the 52nd term of this sequence, you would take that 2 and you would add 51 threes, which means you would add 51 times that difference between the numbers. And we get that 51 from the n minus 1. Now we also have a recursive equation for finding the next term in the sequence. That recursive equation is a sub n equals a sub n minus 1, which once again means the previous term, plus d, which is your difference between the terms. All right, so let's look at example 1 here. In this example, it says if a sub 1 is equal to 8 and a sub n is equal to a sub n minus 1 plus 6, then what is the value of a sub 51? So a sub 51 is your 51st term. Now the formula, once again, was a sub n equals a sub 1 plus n minus 1 times d. Well, your first term here is 8. The n value is 51, which means that goes right in here. That gives us 51 minus 1. And then our difference, well, the difference we can get from your recursive equation, because your recursive equation is a sub n minus 1 plus d. And so 6 is your common difference here. All right, so working this out, this is 50 times 6, which is 300, so that comes out to 308. All right, I want you to pause the video and take a second to write this problem down and work this out on your own paper. And then unpause the video and you can see the result. All right, so this is using the same formula, a sub n equals a sub 1 plus n minus 1 times d. You got to be careful though, this time I did not give you a sub 1. What I did give you was the second term is 49. Now, if your difference is negative 3 and your second term is 49, that means that your first term had to be 52. So putting 52 in the equation for a sub 1, put everything else in here, works out to negative 59 when you simplify that down. All right, so in this next problem, again, we are still working off of the same formula, a sub n, a sub 1, n minus 1 times d. This time we are looking for the 29th term. The first term has been given to us as negative 11. N is 29. Now this time we are not given the d value. We need to find out what is the difference between the terms. All right, so we can find that difference between the terms by taking a look at this sequence down here for just a minute. All right, so in this sequence, a sub 1, which is our first term, is negative 11, and a sub 5, which is our fifth term, is 5. What we want to do to find the difference is we need to figure out what is the distance between these two numbers. That distance would be the larger number minus the smaller number, which is 16. Now, what we're going to do is take that 16 and we need to divide it by the number of times we did that difference. So to go from here to here, we added once, twice, 3 times, and then 4 times. All right, so what that means is we need to divide by 4. Well, if you look at the term numbers here, this is the first term and this is the fifth term. So the way we can get what we're going to be dividing by is take the term number of the upper bound and subtract the term number from the lower. And so that would be over 5 minus 1, which is 4. That gives us a difference of 4. That's what we put into our equation here, and then do the arithmetic to work this out. So this ends up being 28 times 4, which is 112, and then adding in you get 101. All right, just like before, I want you to take a second to write this problem down, pause the video, and then work the problem, and then unpause the video and you can see the result afterwards. All right, so in this situation, the distance or difference between the terms comes out to a 3. Since the second term was a 9, that means the first term would have been a 6. So a sub 1 is 6 in this situation. And then 25 goes in for n. Your difference was 3. Working out the math comes out to 78. All right, so in this problem, it's asking what is a sub 1 of a sequence whose common difference is 1/5 if a sub 26 is 7. All right, so let's write down our formula real quick and plug in what we know. The difference we are given is 1/5, so that can go in over here. Now, it says what is a sub 1? So a sub 1 is the thing we're looking for. That's going to be our variable in this problem. All right, so if we think about what term this is, we have the value a sub 26, which means 26 would be the end value. So we can go ahead and put 26 minus 1 in here, and then this term here would be a sub 26. But we know the value of a sub 26 is 7, so we're going to replace this with 7. Now we can work this problem out. 7 would equal a sub 1 plus 25 times 1/5. 25 times 1/5 is 5, which means a sub 1 is equal to 2. All right, like before, I want you to write this problem down, pause the video, work the problem, and then unpause the video for the result. All right, so plugging everything in, we have a sub 32 is negative 76, so negative 76 goes in for the a sub n. The end value in that situation is 32, and the difference was given as negative 2. And then working out the math here, we end up with a sub 1 is equal to negative 14.